Hi, we are going to learn about the third module of our syllabus called lasers and optical fibers. So what is this laser? What is the acronym of this laser? So L stands for the light, A for the amplification, S for the stimulated emission and radiation. So light, amplification by stimulated emission of radiation is the full form of the laser. So why this laser is so much different and unique from ordinary sources of light is because of its properties. What are the properties of the laser is directionality, monochromicity, coherence, intensity and brightness. So let's now have a quick review of these properties of the laser. So what are the properties we have known now? So you can see from this figure, which is very clear, when I take an ordinary source of light which is consisting of many wavelengths, multi-directional, and all are said to be traveling in different direction, different energy, and wavelengths are different, so they are all said to be incoherent. So whereas when I see the laser, the light which is emanating from the laser is monochromatic. It is a single wavelength, same direction. So they are said to be coherent. So this is the difference between the laser and the ordinary source of light. So you can see this, what is the major property that is playing a key role for the functioning of the laser is laser action. What is this laser action? It is based on the amplification of electromagnetic waves by means of forced or induced atoms or molecules. So a laser radiation uses three fundamental phenomena when electromagnetic waves interacts with the matter. So how do they interact is in three different ways. What are the three different ways? Are spontaneous emission, stimulated emission and induced absorption. So these are the three different ways in which a laser can interact with the electromagnetic waves. Next thing is, let us try to understand the three processes in detail. Induced absorption. So let us now consider two energy levels, E1 and E2, and a photon energy. I am sending light in the form of photons. Energy of each photon is h nu. So when an atom which is in the ground state absorbs the energy of the photon and makes a transition to the E1 from E1 to the E2 state, such a kind of process I am calling it as induced absorption. Why it is called induced? Because we are supplying the energy in the form of photons. That is the reason, with the help of external energy, the transition of an atom is taking place from E1 to E2 state. So such a process I am calling it as induced absorption. Next is spontaneous emission. Spontaneous emission, the name itself, it is very clear that without any time delay the process occurs. So as soon as the atom reaches in the excited state, it can't stay there for a long time. So it has to come down to the lower state. So that process of emission of, or let us say the transition of an atom from E2 to E1 state by emitting energy in the form of photon, I am calling it as spontaneous emission. So the lifetime of an atom in the excited state will be of the order of 10 power minus 9 seconds. You can imagine how quick and the short lifetime is for an atom. Next comes the stimulated emission, which is the most important emission for the functioning of a laser. So you can see the two energy levels similarly, and when an atom reaches in the excited state, which is called as metastable state. What is the meaning of metastable state? In which the atom stays there over a period of 10 power minus 3 seconds. So it is quite stable than ordinary lifetime of an atom. So it can't jump to the lower state on its own. So when an atom of suitable frequency arrives it makes the atom in the metastable state unstable. Then the atom makes a transition from higher to the lower energy by emitting a photon. So that emitted photon is in coherence with the incident photon. So this is the main reason how the laser is functioning. So these are the three different properties of the laser. So we understood now the three processes, and now let us try to understand what is the relation between the two populations of two energy levels that is given by the Boltzmann factor. So under equilibrium conditions, that is at constant temperature, the ratio of population of two energy levels is equal to e power h nu by kt. N1 by N2 is equal to e power h nu by kt, where N1 is the number of atoms which are present in the lower energy E1, N2 is the number of atoms which are put up in the E2 state, and mu is the frequency of the light incident, h is the Planck's constant, k is the Boltzmann constant, and T is the absolute temperature. So this is the relation which is giving between the populations of two energy levels. Now let us try to understand the basic requisites of the laser. So what are the basic requisites of the essential requisites of the laser is active medium, laser cavity, population inversion, pumping, metastable state. So these are the things let us try to understand in detail one after